Alright, welcome back to part 2 video. Picking up where we left off in nonlinear functions. We're on page 2 of the lesson 3 day 1 notes. We have things that are called maximums and minimums. So you can see from the picture, this is the maximum is the top of a hill, and the minimum is the bottom of the valley. So let's see. Nope, that's not a max. Try again. Maximum, top of a hill. So the point at the very top before it changes direction. Minimum, bottom of the valley. Point at the very bottom before it changes direction. We're going to be using them. You look at number 4 to help. Actually, it's after question 4. We're going to be using them to help describe where the function is increasing and decreasing. And if you recall, that was our goal, is to be able to describe where the function is increasing and decreasing. So starting with number 4, we are just being asked to determine and state the coordinates for any maximums and minimums. Your paper should still show the grid fairly well. At the top of the hill here, that is my maximum. Follow it down and over. What shows on your paper a little more nicely should be that maximum occurs at -1, 4. Repeating this process for the minimum looks to occur at the point to -2. And that's it. That's all we're doing here. Part of why we have to identify them is because they are going to then help us to determine our increasing and decreasing intervals. The maximums and the minimums are the turning point. Like what you see is that the function is increasing until that point and then decreasing, or vice versa. If I look back here at this example, you always read our graphs from the left side to the right side, so I'm increasing to that point. Then I am decreasing as I move along from left to right to this point where it turns again, and I am increasing. So that's why they're called turning points. It's where we change direction. We're going to use our maximums and minimums here to determine the turning points for increasing and decreasing intervals, and we're going to write those intervals. So the thing you need to know with intervals, it is x values only. This is really, really important. Like, yeah, when we get our points, we might know what y is, but we aren't concerned. We are only ever creating intervals off of the x-axis. What values of x does this occur for? As we do our intervals, we're going to have to use some inequality symbols, the less than and less than or equal to specifically. We will use a less than symbol for when I have positive infinity, negative infinity, or the second time a number is used. I will use less than or equal to for the first time a number is used. Okay, so this will make a little more sense as we get going. So if we look at number 5, we're going to use the turning points to help you. So remember, we read our graphs from the left to the right. So by the nature of this graph, this side is going down forever, so it's going to approach negative infinity. This side is going down and continuing on forever. But again, remember, we're talking about x values. As it's going down, it's going out, so it's going to approach the x value of negative infinity. Here, while it's going down, it's still going out, so it's going to approach the positive x value of positive infinity. My turning point right here is what? 2, 4. So when I describe the increasing and decreasing intervals, I don't worry about what order they're listed on the page. Moving from the left side to the right side. From the left side, I'm starting with x equals negative infinity. In which direction am I going? Am I increasing or decreasing? I see that going up to this x value of 2. So I'm increasing from negative infinity to 2. So it's negative infinity less than x less than, and because it's the first time we use the 2, or equal to 2. I'm saying start at negative infinity and you're increasing until 2. So then what happened? Well, then that's my turning point. Starting at 2, I'm now going to decrease forever until I get to that positive infinity. So start decreasing at 2. I've already used it before, so just a less than. And then I continue that along the x-axis until infinity. And again, positive and negative infinity get no equal sign because it's not actually a number. You can't get to something exactly infinity. And that is it for that interval. And this question's done. So now checking out number 6. Or no, 5b, excuse me. I need to get my turning points. Again, on the left, the x-axis is approaching negative infinity as it continues to go out. And on the right, the x-axis would approach positive infinity as we continue to go out. And then I need to get my turning point. So this one is about here, a little bit beyond negative 1 on my x-axis. Looks to be between 0 and 5 there. Negative 5 on my y-axis. So I decided this is negative 1.2, negative 2. And then the maximum right here. And following it down, following it over. Set it looks to be about 0.5, 1. So again, we're only concerning ourselves with x values. So we start on the left-hand side, working our way to the right-hand side. So what direction am I going as I move from the left to the right? I'm going down, so it's decreasing from negative infinity. So less than, x less than, to the negative 1.5. I'm sorry, negative 1.2. So that's the first time I wrote that number. I'm putting the equal sign on. I'm changing direction from negative 1.2 until 0.5. I'm going up again. So I start at negative 1.2, less than x, less than. First time I'm using that 0.5, put an equal sign. Change this direction again. And now we are decreasing again from 0.5. It goes on forever until we reach infinity. So starting at 0.5, less than x, less than. And then I was going on until infinity, so no equal sign. That one's done. And so it seems kind of awkward, but again, you're only ever concerned with the numbers off the x-axis when we do these intervals. And it's a pretty similar pattern every single time. So you turn into the homework page. Yesterday you had homework to do 1 through 12. So now we're looking at the back of the page. And this is going to be our homework. You're going to tell where it's increasing or decreasing and identify any maximums or minimums. And it's going to be the whole back of the page because it's important stuff that we have to keep using and we need to practice. So let's see, how about we start, I'll show you number 15. Start with what we know. On the left side will be where it approaches negative infinity, the right, positive. Finding kind of the max here and in here. So I'm going to write that. Max. What is that coordinate? Let's see, negative 3 to 22. So the point negative 3, 22. And the minimum. Same procedure. So this one is a positive 3, negative 14. Max and min part is done. Why did I do those first, even though they were listed second in the instructions? Because you're going to need them to do your intervals anyway, so you might as well do them first. Now for the increasing and decreasing intervals. Starting on the left side, which direction am I moving? Let me see, I'm going up from negative infinity to that max of -3. So I'm going up. Come to increasing, negative infinity, less than x, less than. Going to that -3, I haven't used it yet, so I put an equal to on my less than symbol. So be less than or equal to -3. I'm changing direction. Now I'm decreasing. Decreasing from -3 to my minimum. So from -3 to 3. So start decreasing at -3, less than x, less than. I already used the -3. I don't put anything on that less than symbol. I was decreasing until this minimum of 3. First time I use that 3, it gets an equal sign. And then I am increasing again. So I am increasing from that minimum of -3 to that infinity symbol up there. So from 3, less than x, less than, to infinity. Again, I already used that +3, so I don't put an equal sign, and we never put one on positive or negative infinity. That question is done. Alright, so how about we can do one more. Look at 18. Negative infinity for the left, positive infinity for the right. The maximum at -5, 80. And the minimum, 3. And -5. About halfway between -0 and -10, so I estimate it. Max -322. Min 3 -5. And for my increasing and decreasing intervals. So starting on the left, I'm starting at negative infinity, going up to -5. So it's increasing. Negative infinity, less than x, less than, stopping at -5. Negative infinity never gets an equal to. It's the first time I use that -5, I put an equal to on it. Alright, now I'm changing direction. Now I'm going down from -5 to 3. So -5, less than x, less than, stopping at 3. It's the first time I use -5, no equal to. Or sorry, that's the second time I use the -5, no equal to. First time I use the 3, so now there's an equal to. And then I am increasing again from 3 to infinity. So starting at 3, less than x, less than, stopping at infinity. Second time I use the 3, so no equal sign. Infinity never gets one. And this question is done. If you are having any questions, you need some help, please come and see me. And good luck. So finishing this page, and I'll see you on lesson 13, day 2.